a discussion regarding like why we need to study Java. I told you that Java is one of the languages that can be placed in any part, any of the software development phase. Okay, like with the database, with web base, with object oriented and and then with you know, like graphics. You can do graphics as well, graphics, and also like machine language also. You can work with this networking also. So the application of Java is very vast. So one of the application is database programming. That's we'll see that how basically the database programming can be done with Java language. Okay, so that's today's focus, today's class focus. So we are going to talk about the database, especially a database model. So data model, which is basically relational database systems. So think about in that way that we have several databases. We can have several repository, data repository. Those are called database. Those are called database. Okay. So we have the user. So this is our focus, that user should have to connect the database. User should have to access the database and collect the data and place the data in an organized way. So our focus is that user and database. So in the middle, to support the user, Java has provided, Java is supporting to the users through connections with the application programs. Okay, so connection to the application program. So Java supported to build this application program. So these application programs, we have like graphics user interface or web-based systems. So those are the interfaces we have. So those are basically built in Java. Okay, so those applications will be built in Java, which can be a graphics user interface, desktop-based interface, or that can be the web applications or web interface we can use. So both can be supported. So that's a good sign we have, like both can be supported. Both APIs can be supported in both ways. That can be in web-based systems or in graphics user interface. So that API will support the user to provide their instruction for the database. Okay, like the SQL command, select, or like the interface we had, like PSP admins XAMPP interface we had. See this interface. Let's see this interface. That's basically we are talking about, like this interface, like XAMPP interface. XAMPP interface. So when you go to the XAMPP interface, this one is a web-based interface. Okay, this is not like desktop interface. Although we are working with desktop-based systems, but this is not a desktop-based system. So this one is basically on web-based platforms we are going through. So web-based systems we are taking. So local host, and then semicolon we have 8080, and then we have PSP and main. So this one is basically the URL will provide. So web-based applications. So through web-based, we are accessing the database. We are accessing and managing the database. So this one is the interface by creating, let's see, creating by Java. So this one is interface creating by maybe PSP or some PSP admins or something like that. But think about that this interface has been created by Java. So you can give the commands to the interface. So interface to the interface, this command will be executed, right? So that this kind of interface, Java will provide the API for builds, like this APIs. So you can call the API, and this API will automatically connect you to the system, to the database systems. Okay. Now the concern is that, but we have different, like this one is for MySQL, but if you have Oracle also in the database, so this one can be suitable to connect with Oracle? No. The PSP admin will not support you to connect with the Oracle. So, but Java API supporting you to connect with MySQL as well as the Oracle. So all the systems have same APIs. So it's a generic API. Okay. Now we have the generic APIs. So this one is for all the database, whatever the database is, what is the database management is. So it's basically will be the same for everyone. The GUI or web applications APIs are all same. Okay, for any kind of database. We may have several databases. Okay, so these databases, like, so database can be manipulated by database management systems, like manipulate or process. So What are the commands for processing? That will be given by the application program, and application program will connect to the database management system. So database management system is basically a program that had been created by the professional programmer. So they create some modules, according to the APIs. I mean, the API, they have the generic processing units. They have the generic processing unit so that any MySQL can work with these database management systems. So when you buy the CD from the shop, so you are buying the database management system where we can store data and we can manipulate as well. So that's why this one is called database management systems. So that has been created by the special programmers. Now, for application user, when they use, so their applications will connect to the database and then access the database. So we are creating this part. Basically, our focus is this one. Our focus is this one. Our focus is not this one. We are not caring about this one. So this one already built in. We are not caring about those things. Those are built in. So, and here API is also built in. So we just need to call those APIs, call those method, call those class, call those objects. We have to create the objects. So those has been already built in. So these APIs are already built in. So these APIs will connect to the database management systems, and with the help of database management system, they can access the databases. Okay, so that's basically the relational database systems we have. Now, when you say the data models, like how to represent the data, so data models, there are three things is very important for the data models. Data models. The one point is the structures, like how it looks like, how it can put, where it can store the data. What is the structure of the models? So data models, how do you maintain the data? How do you store the data? That's basically called a structure, where you are placing the data. And then another one is the constraint, integrity constraint, consistency constraint, integrity constraints. So the constraints, so how you are basically filtering your data, what kind of things you want and what kind of things you avoid. So this kind of things will be referred by the constraints. And then we have language, how you are going to manipulate or access the data. That's basically called language. So first we are going to talk about the structure of the relational data model. The structure is basically called relations or table. Okay, the name of the structure is basically table or relation. Let's think about in a way so that you can understand about object-oriented and the database, the connection between object-oriented and relation. So that's, you have to understand. Like when you have a class A, so you should have some instance variable. Like let's see class A, let's see we have class circle. So circle is a class which can have some instance variable. Let's see radius is the instance variable, right? Radius is an instance variable. So this one is like integer type radius is instance variable, right? So this instance variable will refer the characteristics of the circle, how circle will behave. So that will be depending on the radius. So the circle objects, actually not circle objects will behave that depending on the radius. If radius value 2, circle will different. The object of the circle will different than if radius is 3 or radius is 10. The circle area will be cover more area when radius will be increased, right? So that way basically when you are defining a class, the class can have two things. One is the instance variable, and another one is the class variable. I'm not talking about class variable, I'm just talking about instance variable, and I'm talking about method, right? So so methods are basically manipulating the instance variable. So main focus is the instance variable. So the characteristics of a class is basically represented by the instance variables. So instance variable change, the characteristics has been changed. Like if you talk about a human, so human has some behavior or characteristics that's distinguishing him from the animal, like other animals. So like human has a brain, human has intelligence, other doesn't have. So those are the characteristics that can make the individually different from other animals. So that's way basically the class can represent. So when we create the objects basically, so object basically a1 equal to new, let's see, circle. So new circle, let's see, circle here, new circle, let's see, the radius is 2. So this one is totally different with the circle a2 equal to new circle, radius is 10. So radius is 10. So circle will be called with radius 10. So this circle and this circle is totally different. How do you differ these objects? How do you differ the objects? The objects are different. Why? Because the value of the instance variable are different from one to another one. So the distinguish between object to object is basically making by the changing the value of the instance variable. The same way, think that the features are basically attributes, or features are basically representing the objects as like the instance variables, like circle, like tire size, like pi value. So those are basically representing the circle. So circle behavior can be changed. If anyone will change, the circle behavior will change. So that's why basically a table has some attributes, or a relation has some attributes. That is basically providing that what type of table you have. So the behavior of this table, like course is an object. So what can be the behavior of these objects? Who can refer? So that's reference will be done by the, let's say, course is a class name. So course is a class name, and the columns and attributes are the instance variable. If we change any value, then the object value will be changed. So these are the instance of this class instance. That's mean those are objects. One object. So one row is an object because they got the value of the instance value. So everyone is an instance of objects, and they are unique from one to another one. They don't have connections. May have relationship with the course ID, but they are independent from one to another one from the value. The values are different in total. Cumulatively, the value is different from one to another one. So that's where basically we have one constraints in here, that the table should have, the relational table should have non-duplicate rows. Rows are basically called instance of objects with different values of the attributes. So attributes are the instance variable. You can think about this way. So you can refer in this way, right? We do these things in C#. When you go for this one, we learn these things about the context class. About the context class, we represent the same way, right? Context class. So every data set is basically one row of the table. So that's where basically we can use context class to create a table, one context class for one table. So I mean, context class, the object is basically referring to the table. So that's where basically we can create the class, and so that's where basically we can create the class and the relationship between class and objects. The same way we can relation here that attributes represent the feature of the objects, as well as the tuples are representing each one's are instance of objects, class of the instance variable and instance of classes. So each ones are instance of one classes, each one is classes, right? So that's why this name is class. Now the point is that here in database we can say that this one is a tuple. So columns are tuple, and columns are attributes. Columns are called attributes or features, okay? Whereas the rows are called tuple. Rows are called tuples. So cumulatively, one row value is different from another value. Like in total, the row value is different, must be unique from one to another one. Otherwise, this row should not be staying in the table. So that's basically called a relation. So this is the structure of the relation. You may have more than one relation as well, like students table we have, enrollment table we have, and they may have common attributes as well. Like here course ID we have, and this table we have course ID. Here subject, here we have the SSN. Here also we have the SSN. So in that way, so enrollment has Neural can access both tables informations by using this SSN and common attributes of the tables. So by using those, okay. So we will elaborately explain those things later, okay. So, so the variables or the attributes value. These attributes value representing information for the information for the student table. So that's mean student instance. So each are one students. Okay, each are one student. So they have an example of the data sets, okay, so which can represent a student. So those are basically in here. So that's what I'm telling. So you can take that student is a class and each one is an objects. Each one is an objects and attributes are representing the characteristics of the students, okay. So those values are representing the objects, how he is, how the student is. So each one is a student, okay, fine. So the attributes basically providing the attributes, basically we can from the attributes we can understand the relationship of the data. So here we have many data. So the relationship we have inter-table data or relational data will tell us that okay, intra attributes will tell us that the relationship between one tuples to another tuples, what is the difference between them. Whereas when you have two tables, so that tells the intra-relationship, how this table will be related to this table, how this table will be related to these tables. So that's we can find out by intra-relationship informations by using more than one tables who has common attributes. Okay, so now we are coming to the structures. We have already learned the structures, and now we are coming to integrity constants. Okay, integrity constants, there are two types of constants. One is called inter-relational constants. That's mean in a table, so only one table we have, one relation we have, and in that table, in the attributes, you want to put some constraints in there. So that's basically called intra-relational constraint. Like domain constraints or primary key, those are basically set up in a single table. Those are basically set up in a single table. So they reflected the interrelationship constraint. Whereas we have foreign key, which required more than one tables, and the table must have some common attributes, which is basically called foreign key. So usually the primary key can be set up as a foreign key in the other tables. So in this table, maybe he is a primary key, but other table he can be a foreign key. So more than one relation is required to inter-relationship constraints to be provided. So like foreign key can be provided. So foreign key helps us to interrelated relational constants. So more than one relations is required to represent with a foreign key. Now let's go for let's go for integrity constants, more details in the examples. Like see here we have number of credits. Number of credits is we have 433. So number of credit has a constraint. So these attributes value has a constraint. The value, that's mean the value will come from a place which is domain. So that will come from a place which is domain, a set from a set of values. So domain is a set. So from where the value will come, the value will arrive in number of credits. Number of credits as a domain. So this domain is like value will come from 1, 2, 3, 4, 5. So this is my range. So this is my value. So this can be implemented in number of credits as a number of credits. So now inside the number of credits we have 0, 1, 2, 3, 4, 5. So those are represented by tables. So domain tables. We are restricting that to allow only 0 to 5 values, not more than that. So that is the restrictions is called domain constraints, because where from the data will come, you are restricting those data. So you are filtering those data that only 0 to 5 can come here, otherwise the other value will not be acceptable in this case. So that's why the domain constraints, you are applying the constraints on the domain where from the data will come. So the data source, where from the data has been arrived, so data source. Whereas another one we have like this one, that this one is course ID, which must have we are telling that this course ID must have a unique features, So Number of caret belongs to, so number of caret, you can say the number of caret is um, 0 to 5, right? So number of, in that way we can represent. But the course ID, so it's the course ID column. We are telling that this domain of the value, where from the value will come, must be unique from one to another one. So if we have 1111 and if we have 1111, so the domain is not acceptable because this one is not supported in here. Okay, it should be unique. We say the domain of this attribute should be unique. So that means that course ID should have unique value, cannot have two values. So from two values, you cannot get the data. Every value should be on state. Every value should be unique. Okay. Now this one, these are called intra-relational constraints, where we have inter-relational constraints. Like here, you see the course ID and course ID. Each value of the course ID in the enrollment table course ID must match a value in the course ID of the each column. That means this course ID has a representation in here as well, a course ID. So if you want to find out, let's see, if you want to find out that one course like this one, the title course is Introduction to Java 1. How many students got A? How many students got A? How can you find out? So select all from enrollment so count grade. Or you can see here, start, select all, select select SSN or course ID. Okay, select all from course ID where count grade, where course ID, where course title equal to Introduction to Java. So course title, rather than course title, you have to use course ID because we have a common course ID. So course ID equal to 1111, so which is basically representing Java. So now 1111, if you find out that 1111, how many person has count grade? So the grade will be counted. So here can also basically count grade. So count grade, not all, count grade. So you will, grade will count where the course ID is 111. So 111, how many 111? So all the grades you will count. How many grades you got? 1, A, B, C, D, like that. Or if you want to find out count grade where grade equal A, okay, and grade equal A. So what I want is that, okay, so course ID, so okay, and course ID is 1111. So if this course ID joining this table into two different tables, you see that we know that the title has a course ID. So that course ID is a course ID in here. So we are searching that which has a course ID 111. So we can select the name in here, like the title name. So there is a foreign key. What is this called? It's foreign key. Like course ID is here, is a foreign key. Foreign key. Why foreign key? Because this one is another attribute. This one is from another table attribute. So that's why this one has a foreign key. This one name is foreign key. Usually the primary key of a table can be a foreign key of other tables, so that we can do, because any kind of SQL processings we can do by using the primary key, right? So that's why the primary key can be a foreign key of a table. So that will help us for searching issues. Okay, so that's I will discuss that how foreign key will come. Okay, so now let's talk about a very important part, which is called primary key and which is called foreign key. So what is primary key? Let's find out this one. How to represent a primary key? Okay. Yes, Ibrahim. Yeah, primary key must be unique, but I'm telling that how it will come. Okay. Let's see first. We are coming super key. What is super key? Super key is an attribute or a set of attributes that uniquely identify the relation. Actually, relation tuples, not relation tuples. That's mean the row of the relation that uniquely identified the row of the relation. So that's basically called super key. Like this one. If you go for this one, let's see course ID, course number in here, right? Forget about the other attributes. Now about these attributes, title. These three can be, these three are distinguished, like in title, they are unique, right? So they are different from one to another one. So title is making the row different because one attribute is different. That means the full row is different. In a similar way, course number is also different. So course number is making different from one to another one. So one to another row. So that's been tuple to tuple difference. So this one is also helping different. You can say course ID number is also unique and they're also different from one to another one. So that's mean he is also making the total tuple different from one to another one. You see that subject ID are same. So he cannot be a super key because he has common keys between at least two tables. So that's why, so it cannot be a super key. Which key making, like a key or a attributes or a combined attributes can make the relation, uniquely identify the relation or uniquely identify the tuples. That's basically called super key. Like here, course ID and course number. If you merge these two together, collectively, these two, 1111 and 1301. So there will be no table which has one, there will be no tuple which has 1111 and 1301, maybe 1302. So that times we have this together, these two key will make us a differentiate the rows of the each row of the table. So like if you combine all the attributes collectively, all the attributes of a table collectively, the rows are must be different from one to another one. So tuples are different from one to another one. So all the attributes all the attributes collectively are making different rows from one row to another row. So that's why all the attributes collectively are called super key. Or any one attributes or any two attributes combinedly make it different. So those are also super key. Like course ID and course number together can making different as well. So those are also super key. As well as title itself is making different. So this is also super key. Course ID itself making it different. So this is also super key. So as I'm telling that super key is an attribute or a set of attributes that uniquely identifies the relation tuples. Inside the relations, the tuples will be identified different from one to another one. Who is making the difference? That is basically super key. Okay. Well, so that can be one, that can be two, that can be three, or that can be all the tuples together. So super key. Okay, anyway, so a set of attributes are defined as super key. A set of attributes are defining a super key. A set of attributes can define a super key. By them, combinedly, they can differentiate each tuples. Okay. Now, a key is a minimal super key. Minimal super key is a pure subset of super key. That means it is a subset of the super key. Minimal means like if a set has super key like four key together, combinedly four key together, like 1, 2, 3, 4, 5 key together, then the minimal one of this one is one key that is making distinction different from one to another one. So that's the way of telling that a minimal super key, that's mean the size means attributes. The attributes number is minimal. So that is basically the super key, which has like all the super keys, which is the minimum one. Okay, so that's basically called a key. This is basically called key, like course ID, course number, title. Those are basically key. Each one's a key. So those are also called, there may be several keys in the relationship. There are many keys in here. Each of the keys are called candidate key. So every keys are called candidate key. Okay. But now we are coming to that, a candidate key which has a uniqueness. Obviously uniqueness because they are distinguishing tuple. So obviously they are unique. Okay. And also not null. The value is not null. And that will be selected by the designer. Like you are selecting, you are the programmer, you are selecting the course number is basically the primary key. So that times course number will be distinct from one to another one, and also it will be not null. Okay, not null. It will be distinguished and it will be not null. Then this one is called a primary key. So primary key is a candidate key, but will be chosen by the programmer in his design. Programmer in his design, that which one you want to choose as a from the keys, candidate keys, which one you want to choose. So you are choosing like course ID. Okay, fine. Then course ID is the primary key for this table. Okay. Okay. Now, if you have multiple tables, so you have multiple relationships. So between relationship, common attributes are called foreign keys. Common attributes are called foreign keys because these attributes, the common attributes, are also an attributes in different table. His attributes in my table, and his also attributes in different another table. So that means that he is a foreign key in there. Okay, so foreign key usually the primary key in another tables, another relations or another relations we have another tables. The primary key can be a foreign key of another table, so that we can search easily through the primary key, right? So any questions you have? Do you have any question? What is super key? You understand? The key which combinedly or alone, standalone, can differentiate the rows, the tuples, uniquely identify the tuples. That's basically called super key. And what is key? The minimum size of the super key is basically called a key. And what is candidate key? There may be several keys, so all are candidate key. These are basically candidate key. Now, what is primary key? From the candidate key, anyone the programmer is choosing as his design of the database, he is choosing that this one, design of the relationship, relation, he is choosing that this one is my primary key. So that is basically the candidate key will transfer to the primary key. Okay, but by the primary key also not null. Candidate key can be null, but primary key cannot be null. Okay. So there can be a null in here. So no problem. This one is a candidate key. But when you put this one as a primary key, it should be not null. Not null. There is no value supporting null. Okay. Okay. So please search this one as I'm correcting or not. Like candidate keys are supporting null. Is it okay or not? Can you tell me? Is it right? Can you tell me, is it right or not? Can you search and check? Candidate key is null. Is it okay or not? Yes.
candidate কে null হতে পারবে।
Right. But primary key cannot be null. You understand? Very important issues. Very important difference. All the candidate key you cannot choose as a primary key. You are choosing as a primary key which is not null. Please remember, primary key cannot be null. So that's constraints you have to place there. Okay, but candidate key can be null as well. Okay, because they can distinguish just the distinguish. This is one of the distinction. But there should not be two null in one candidate key. Okay, only one null can be. Okay. Now the SQL structure. SQL structures basically, now we are coming to the language. We are coming to the language now. Like we talk about the structures, then we talk about integrity. Now we are talking about language. So for describing the data model, okay, the language is called a generic language we have that is used for manipulating and storing data and manipulating data. So this is basically called SQL. SQL, okay. Sometimes I used to say SQL, but in our book it's written like SQL, SE, SQL. Okay, so SQL, structured query language, structured query language. So SQL is a universal language for accessing relational database systems. So this language is a universal, that's been common language, which can be used by everyone and which can be used to accessing the database. Okay, so you can use the SQL for creating the table or creating integrity constants, for use for accessing and manipulating data. You can create like word operations, uh, create, read, drop, insert, update, and delete tables. Delete query you can use on the tables that's you are creating. Okay, so like an example, we can say like select all from, let's see, employee. What does it mean? Can you tell me what does it mean? What is the meaning of this one? Select all from employee.
স্যার আপনি সিলেক্ট করছেন ওই টেবিল নেমের মধ্যে যে এই নামের কলামটা এই পুরাটা দেখাবে।
So we are telling that all from employee. So employee is the table name, right? So this one is the table name, okay? And select is the clause that's we are using. So this you can say like command. That's we are making simple one, okay? Not like grammatical words we are not using like clause. We are not using clause. We are using command. Okay, this is a SQL command. So select all. So what is this one? Is all star is all. What does it mean? All rows, all attributes, sorry, all not rows, all attributes, all attributes. What we are telling is that select all attributes. So show all attributes from employee table. So all attributes, if you have like employee ID, then employee name, and you have gender, and you have address. So all the attributes will be shown. So all means like all attributes. You do not write individually. You can write individually here. Like select ID. So select ID, name, okay, and then gender, and then address. So you can select in this way as well. But when you say from employee, so that's you can do. But when you say like select ID, name, gender, address from employee, so and semicolon is in here. So that one you can select all in the same way. So without writing the all of the column name, we are writing the star. So select all from employee. We can make a constraint that we cannot take the full one. So you can take two. So we can reduce that by using like this, select ID and select name. Okay. So employee, from employee. So employee table, from employee table, the ID and name will be selected. So if we have an employee table, so only ID and name for all employees, ID and name will be selected. Now we want to make reductions in the row. We want to make constraints in the row. Like we are not selecting all the rows. We want to filter there. How can we filter there? We don't want to select all the rows. We want to make conditions that this one should be satisfied. So that row should be taken, not all row. So we can use where clause. Where select ID number from employee, ID name from employee, where ID equal, let's see, ID equal 5. Or you can say like address, okay? So address. So ID modulus 5. ID divided by 5 equal, okay, ID modulus 5 equal 0. So that condition is telling that if any ID modulus by 5 equal 0, select only to them. So you are filtering this one. So where clause is providing you filtering the rows, okay? Select clause providing you the filtering of column, and where is providing you to filter the row by where, and select will filter the column. Insert into Then insert into, let's see, employee. So employee table, and then what are the columns attributes you want to insert? Let's see, ID number, let's see, name, let's see, we have ID, name, and then we have what did it, gender, and then we have, let's see, address, address. So those are insert into employee. So those column value you will take, and the values you need to place, the values is what, the values you want to place, the values are like ID equal to, name equal, let's say Rohim, let's say Rohim, and gender equal to he, so male, and address equal like Uttara. Okay, so Uttara. So these are the contains that will tell that these values will go to this corresponding rows and place these rows into the table. Now we have one options for creating auto increment. AI is auto increment. Okay, so we want to create the ID auto increment. So ID will be automatically increase. Okay, that times you do not need to put the ID number, because so that times what he will do is that if there is no ID number, then he will place that one. But if there is an ID number of this one, it will show an exception. So you need to call updates that times. But if it is auto increment, then you don't need to put the ID numbers. Automatically this will place to the last of the table. So that way basically that will work. Okay, you understand? So that's why auto increment, that's why we are not placing the ID numbers, we are just placing the other variables, other characters and their names, other attributes and their name and their values. Okay, so that way basically they will prefer. Okay, now if any value, any variable value is null, supported by null, like address is supported by null, so it's fine. If you don't give the value, it's okay. So if you don't place in here and don't give the value, it's okay. The null value will be placed into the address, which is supporting null as an initialized value, or null has been supported. So automatically null has been placed in there. Remember those things. Okay, those are important when you do program. Now we are going for delete. So delete from employee where, so usually we use primary key for any kind of search in ID equal to 4. So what will happen is that I will search in the tables for ID number 4 and then retrieve this one. It will be deleted from the employee and this one updated in the table. Okay, so now from the SQLs we have find out that there are few SQLs that's providing the output and few SQLs are not providing the output. Like select will provide you the output, isn't it? Select all, so it will show the outputs, right? Select will provide the output, but insert and delete will not provide the output. Insert and delete will not provide the output. Remember these things, okay? They are just modified. Delete, they just modify, they just write. So it is not getting data, it's just writing and it's reading. So it is reading the data. So it just read and it just use write. So we have two functions to API to handle this for these two. Like we have a statement dot execute query. Execute query. So this one is for select. These functions will work for select query. And when you have insert or delete or update, so that time so you're going to use statements dot execute update. Execute update. Remember these things, okay? It's very important. Updates, it's very important, like which one you choose where. So these two you have to remember. This one where from the output is coming, so that one is select, and where we have there is no output is coming, only modification will be done in the table, so that times we'll use execution update. Fine. Now okay, how much time we have? How much?
So it's 5:23.
5 minutes to complete.
Yes, sir.
Okay, then I'm not doing anymore.